Okay, so I just realized I didn't read Shannon's directions very well on this, where it says, calculate these dosages, which we're doing. Express answers to the nearest tenth. So that last one I said was 2.88 milliliters, should be 2.9. Sorry. I'll get it right from now on. And assess answers to determine if they are logical. I like that. I like that a lot. So in that last one, as I was doing the math, I was actually thinking in my head, well, we need 24 milligrams of this substance, and the dosage contains about 12. It was a little bit more, 12.5, but it's about 12. So that means we're going to need 2 dosages of it, right? If it comes in a dose that has about 12 milligrams, we're going to need about 2 of those doses. Now, it's a little bit tricky because the dose itself is 1.5 milliliters. So you're going to have to double that dose. So 1.5 doubled is 3, which is just about what we got, right? We got 2.9. So when Shannon says assess to make sure it's logical, that's, I think, what she's getting at. Like if one dose, 1.5 milliliters, gives you about 12, then 2 doses, 3 milliliters, will give you the 24 that you need. So I like that. I like that. Okay, we'll do that as we go. We'll make sure that the answers we get make sense logically. All right, number 2. Let's take a look at this. A 40 milligram in 2.5 milliliter solution. Okay, so right away, I'm reading that. That's what we have on the shelf, right? We've got little bottles of 2.5 mil solutions that each contain 40 milligrams. That's going to be used to prepare a 30 milligram dosage. So that tells us something right away. 30 milligrams is less than 40 milligrams, which means whatever answer we get has to be less than 2.5 milliliters of solution. That's helpful to know, right? It's going to be less than 1 full dose. Okay, so let's attack this the same way we did before. The same way we did before. We need to give this person 30 milligrams of whatever drug we're giving them. I'm going to put it over 1 because we can make it a fraction. We need on the other end to come out with milliliters. And the conversion we have is that 40 milligrams is in 2.5 milliliters. So that's that fraction that we need. Now, check your units. We need to get rid of milligrams. That means milligrams is going to have to be on the bottom and milliliters is going to have to be up top, right? So let me read that again. 2.5 milliliters and 40 milligrams. 40 milligrams. All right, now comes the fun. We grab our cancellation chalk and we get rid of the units we don't want and replace them with the ones that we do. Get rid of the ones we don't want. Only thing left are the ones we do want. And then all we got to do is do the math. So you're going to do 30 times 2.5. all divided by 40. Notice I'm just skipping right over the ones this time. Like there's a 1 there, there's a 1 there, and there's a 1 there. But multiplying and dividing by 1 doesn't change anything, so I can just focus on the actual numbers that are there. So it's going to be 3/4 of 2.5. I want to make sure I get this to the correct precision though, Shannon. 1 decimal place. I'll be right back. All right, so to the correct 1 decimal place, I get 1.875, so round it off. That's going to be 1.9 milliliters of solution. This makes sense because it's less than a full dose. A full dose gives you 40 milligrams. We have to give a little bit less than that. And this is how much less you're going to give that person to get that desired 30 milligrams. So we rounded off to the correct place, 1.9, yay. And we also checked our result to make sure that it actually makes sense. Since we need less than what's in a full dose, we have to give less than a full dose. Sweet!